Hi, my name is Lim Ziyang, the leader of the Curious Scientists. My team members are Lim Kun Heng, Lim Xiaoqian, and Li Chenglian. Today, I'm here to talk about the principle of magnetism. Did you know that the Earth itself is a giant magnet? The Earth gets its magnetic field from circulating electric currents within the molten metallic core. What I want to share with you is about the principle of magnetism, electromagnet, and application of magnetism. A magnet, in the simplest form, is a material that generates a magnetic field. Magnetic field sources are dipolar, having a north and south magnetic pole. Opposite poles attract and like poles repel. Now, I will conduct an experiment to show the properties of magnet. In this experiment, you need two plastic bottles, bottle cap, straws, wooden sticks, and permanent magnet. First, create a car model. Next, mount magnets at the front and at the rear of the car. Lastly, mount a magnet on a wooden stick. That's all, it's done. So, how to make the car move without touching it? When you place two light poles of magnet near to each other, they will repel each other. As they repel, the magnetic force will cause the car to move forward. To apply both properties of the magnet at the same time in this model, you have to create another model same as the first one. As the magnetic poles are different, the cars will attract each other and join together. So, you can move two cars at once by pointing the light pole of wooden magnet near to the rear magnet of the first car. That's it, the basic principle of magnetism. After watching how magnets attract and repel, do you feel excited to know what an artificial magnet is? An artificial magnet, also known as electromagnet, it is a type of magnet in which magnetic field is produced by an electric current due to the Ampere's law. Now, I would like to show you an electromagnet lifter that I created using household recycled item. First, you need to get a metal board, some copper wires, battery cells, and switch. This is the setup of electromagnet lifter. Now, let's get some metal object to try out. Yes, as I switch on, it attracts the paper clip. In practical, as you switch on, the current will start flowing and electromagnetic field is created. If you move the head of both toward a metal object, it will attract the object toward itself. On the other hand, if you switch off, the electromagnet will stop working. Yet, why is it so? Electromagnets are made of coils of wire with electricity passing through them. Moving charges create magnetic field, so when the coils of wire in an electromagnet have an electric current passing through them, the coils behave like a magnet. So, what are the factors that affect the strength of electromagnetic field? First, the magnitude of current carried by the coil. The higher the current, the higher the strength of electromagnetic field. Second, number of turns. The greater the number of turns, the greater the strength of electromagnetic field. Third, type of iron core. Soft iron core will help concentrate the magnetic field to produce a stronger field. In the third experiment, I will show you how electromagnetism turns electrical energy to kinetic energy. What you need is a battery cell, two metal safety pins, copper wire, wooden block, and permanent magnet. As you switch on the current, the copper coil may start spinning. It's amazing, but there's a perfectly scientific explanation. How does it work? When an electric current starts to flow along a coil wire, it creates a magnetic field all around it. As the permanent magnet near it, the temporary magnetic field around the coil wire attracts or repels the permanent magnet, and that's what causes the coil of wire to rotate. The applications of magnetism are nearly countless. It's used throughout the modern technology, particularly in electrical engineering and electromechanics. That's all for now. Thank you so much for your interest and attention. Hope you like it. Bye.